Hi, in this video, I'll go through some binomial probability problems. I will talk about the binomial probability formula, not quite deriving it mathematically, but I will explain where it comes from and why some of the common wrong answers are wrong. And then I'll show how to use StatCrunch to compute the answer. Let's take this example. A student randomly guesses at answers to a multiple choice exam. Each question has 5 options, A, B, C, D, E, and there are 10 questions in the exam. What is the probability the student gets 3 questions correct? This is a binomial question because all the binomial conditions are met. First, is there a fixed number of trials? Yes, each try in this case consists of 1 attempt at guessing an answer, and we're told there are exactly 10 trials. N is fixed at 10. Second, does each try have exactly 2 possible outcomes? Yes. We asked about the probability of having 3 questions correct, so the variable of interest is correct versus not correct. We define success as correct because that makes it easy on the computation. It's consistent with the question asked. Third, are the trials independent? And/or is the probability of success fixed? Note that some people teach these as 2 separate conditions. Here we have both. Yes, each guess is random and therefore independent. Also, the probability of success P is fixed at 1 out of 5, or in other words, P equals 0.2. So we have a binomial process. And in a binomial problem, the question typically asks for the probability of getting a certain number of successes. Here, the question is the probability of getting 3 successes out of 10. This whole word problem can now be summarized like this. It's a binomial question. N equals 10, P equals 0.2. And we want to compute the probability of x equals 3, where x is the number of successes. But first, why isn't the answer something simple like 3 out of 10, 3 over 10? This is why, because 3 over 10 is a different probability. It's if we have 10 questions and 3 are already correct. And we're asked if we pick just 1 question at random, what's the probability we get 1 that's correct? That's a totally different question, and one of the differences is that it's the probability of 1 attempt. How about this answer instead? Also a common wrong answer that I see on exams. If each answer has a 1 out of 5 chance of being correct, why isn't the answer 1/5 to the 3rd power for, 3 correct answers? 1/5 to the 3rd is wrong because it means the probability of getting correct and correct and correct, meaning 3 correct answers in a row and then stop. It's the probability of 3 attempts and getting all of them correct. That's still not our situation. Our situation is 10 attempts and getting 3 correct. You might think, okay, how about this one? 3 correct answers, 7 incorrect answers. That makes it 10 attempts, doesn't it? Good guess. Very close. Not quite. What you're giving me is this. 3 correct answers make the 1/5 to the 3rd, and 7 incorrect answers, that's the 4/5 to the 7th power. 10 trials, 3 correct. Very close, but still incomplete. Do you know why? Because this is only one way of getting the 3 correct answers. There are many other possibilities. The 3 correct answers can come from anywhere. Once you have the 3 correct answers, then yeah, the other 7 are incorrect. That is true. But the 3 correct answers can come from anywhere. They don't have to be the first 3. And each of these other possibilities also has the probability of 1/5 to the 3rd times 4/5 to the 7th. Each possibility has that exact same probability, and we just need to count how many possibilities there are. And there are as many of these as there are ways to pick the 3 spot for the correct answers out of 10. Therefore, the answer should be equal to 1/5 to a third times 4/5 to 7 times however many ways to select the 3 spots for the correct answer out of 10. That particular portion of the answer, how many ways to select 3 spots out of 10, that's a known mathematical quantity. It's called a combination, and we read it as 10 choose 3. There are 2 notations for it, either 10 choose 3 with the letter C, or 10 choose 3 vertically inside the big parentheses. The official name for the 10 choose 3 with a C is called the combination. And the official name for the 10 choose 3 vertically on top of each other is called the binomial coefficient. Now that we have a notation for that number of ways to select 3 spots out of 10, we can write the formula for the binomial probability. Given the binomial process B, n, P, where n is the number of independent trials and P is the probability of success, the probability of getting X successes is this formula, where we have the P to the power X for the X successes times 1 minus P to the power n minus X for the rest of them are failures, and then times this quantity for all the different possibilities. So altogether is n choose X times P to the X times 1 minus P to the n minus X. Now I'll do a little detour on the computation of n choose X. There's a formula for n choose X. It looks like that. The exclamation mark means factorial, and it means multiplying all integers from that number down to 1. For example, 5 exclamation mark means 5 factorial, and it equals to 5 times 4 times 3 times 2 times 1. Multiply from 5 down to 1. And that's equal to 120. But people hardly ever compute n choose X manually because all scientific and graphing calculators can compute n choose X for you. So up here, I'm putting a link to my video using the TI-30X scientific calculator to compute the binomial coefficient. And also this link here is my video on using the Casio FX9750 graphing calculator. If you have a TI-83 or 84, there are lots of videos online on how to use them. Just Google for it. If you need to compute n choose X, use a calculator. But in fact, you don't even need to compute n choose X because graphing calculators and statistics software can compute the whole binomial probability directly without going through the formula. So I will now switch to StatCrunch to do the calculations on the binomial probability. All right, so here I am in StatCrunch, and the problem I'm looking at is binomial with n equals 10, P equals 0.2, and I'm looking for the probability that X is equal to 3. On StatCrunch, the binomial calculation is under Stat, Calculators, Binomial. Stat Calculators, Binomial. I click on that, I get this pop-up window. It says up here binomial calculator. I fill in the information, n is equal to 10, P is equal to 0.2, and I fill in this probability. I want X equals to 3, so I click on this drop-down menu and I choose the equal sign, and I change this number to 3. I click compute, and I have the answer of 0.201. Now let's take a slightly different example. A student randomly guesses at answers to a multiple choice exam. Each question has 5 options. There are 10 questions on the exam. What is the probability the student gets at least 6 questions correct? So it's still the same situation, so it's still binomial, but the question is different. The binomial is still B 10, 0.2, n equals to 10, P equals 0.2, but the question is now the probability of at least 6 successes. It's binomial, so we still go to StatCrunch, stat, calculators, binomial. We're still getting this window. And we're still using n equals 10, p equals 0.2. But now we need to change this math down here into at least 6. At least 6 means 6, 7, 8, 9, 10. So it's actually meaning x is greater than or equal to 6. Be careful about that. I have many students who hear the words at least 6, and the word least makes them think it means less than something. It is not. At least 6 means 6, 7, 8, 9, 10, meaning 6 or more, greater than or equal to 6. Try to imagine the number line so that you can write your inequality correctly. At least 6 actually means greater than or equal to. So here it is, greater than or equal to 6. Click compute, and the answer is 0.00637. All right, let's summarize. Suppose you recognize that a problem could be binomial. Then what you should do is check all the conditions to make sure that it is in fact binomial. Many professors and teachers may also require you to actually write it down on paper, then do that. If the problem is binomial, just remember the straightforward probabilities don't work. If the question asks for something like, what's the probability of getting 3 correct answers out of 10? The answer is not going to be just 3 over 10. You have to either use the formula for binomial or use technology. Chances are your professor or teacher will allow you to use technology. I certainly allow it. And on StatCrunch, the steps are stat, calculators, binomial. Be careful with the verbal descriptions such as at least, no more than, at most. Those words you have to think in terms of what kind of numbers are they talking about so you can write the correct inequality. Hope that helps. Thanks for watching. Subscribe for more contents. Bye.